Okay, and then if I do Control Alt Shift H, boom. All right, let's do it, guys. Welcome to acid-base unit, right? By the way, I did tell you last night, I realized I did want you guys to, if you want to look at your last redox stuff from 2 weeks ago, right? For the upcoming redox electrochemistry, I do realize today ninth period is the only chance. That's why I pushed the exam, right? 1. 2, I also realized my family wanted to watch the Knicks versus Celtics, and then I told them, dude, you can't. We have the family curse. You know what the family curse is?
It's their fault.
If I watch a game and I root for a team, they lose. They lose. Why? Because that, and then guess what? If you sit too close to me, it's gonna rub off on you. Because my college roommate who I went to school with, he told me he used to listen to Yankees and he would put on his little headphones on a radio, turn it on, and it would turn it off. I'm like, what are you doing? And he goes, we have a thing where if we listen to the game or watch it, they start losing. I was like, what? Get out of here. That's the dumbest thing. You're supposed to, he was an engineering major. How are you an engineering major? Listen to this superstition, right? He goes, no, it's true. He has never seen the Yankees win. Even though he's a diehard Yankee, he said, I've never seen them win. They only win when I don't watch the game or listen to the game, right? I'm like, what? That's the dumbest thing. He goes, no, apparently it came from my dad who got it from his college roommate at Wake Forest, right? And then his family went back. It's almost like, what's that Disney movie, Holes, right? You guys know about Holes? That's a great book, right? You know, like the family curse, right? So anyway, he said that. I was like, get out of here. What happened? Yeah. I've never seen the Yankees or Mets win. It's like the weirdest thing. So I told my friend that, and then he's like a Yankee Mets game. He has season tickets. So we went to. He's like, no, we're gonna break this curse. We're gonna go there. We went there, and he goes, holy crap, that's true, right? And then what happened? One game we went, they were getting killed. So on the 9th inning, Mets game, we're like, let's just leave. So we got in the car, we left. We have WFAN listening to the game. What happens? Mets making a comeback. I was like, anyway, so I told my wife that. So she told one of her students, and he's like, no, miss, they're doing really well. And there's like a 95% chance they're going to win. So you should watch it. It's going to be an exciting game. I was like, we start watching. And what happened? Yeah, it's me. That's going to be you. Oh. Moving on. Right? And then he was like, don't worry. I was like, man, I wish you can take a video of this kid's face, because apparently he's like a diehard Knicks fan. And he was like, oh, they're doing great. I would love to see his face when she tells him. Yeah, right? Anyway, moving on. All right, here we go. So anyway, I felt bad because my son was like, you do realize the boys are going to be watching Knicks games. I was like, so how's that my problem, right? They should be doing chemistry. They're like, come on. So, and the fact that I want you to have the opportunity to look at it, that's why I pushed it. All right, so let's go. All right, so we're going to do acid and bases, but you're going to be studying redox electrochem, right? Yes. I put I gave you the review sheet. Did I? Yes. Yeah. I put the answer key for your review book, right? The sheet that I signed, I'm going to post answers to this so you can look at it. Got it? Let's go. So we're moving on. We're chugging along now, right? Now, describes an acid, right? Anybody? Just if I say acid, what do you think? Yes. Dissociates in water. Good. So we're gonna start. And by the way, like I was telling the other class, this is kind of like season 4 now, right? Of chemistry, right? Regents Chem, right? You're gonna notice elements. You'll notice what was fun about redox, because a lot of stuff from previous units were coming back, right? Stuff we learned in season 1, season 2, right, and season 3 were being used, and you're like, oh my god! So you know what I'm talking about? How do you know a good Netflix show? Because you're in season 4 and you're watching, and you're like, oh my god, this is the thing from season 1, right? Or like, oh my god, this is the thing from season 2, right? And then you're like, oh man, these writers, right? How good are they, right? Because they all tied it together, right? In the end, and you feel so good, right? If that's the way you're feeling, you're probably feeling, oh my god, Mr. Kim, he arranged this unit so that it's all coming back together, right? So you're that excited. You're like, wow, this is so interesting. Or on the flip side, you're the student who's like, oh crap, this is the stuff that I didn't study, and now it's killing me, right? Be the first student, right? Now, if you like that, guess what? Remember redox, we need to know a lot of stuff from previous chapters. ions and, oxidation states and charges and all that stuff. If you thought that was fun and you did well, congratulations. If you didn't do well on that because you were weak on the previous material and then that was hurting you, acid-base is going to hurt you just like that, but even more. That's bad, right? Reason why, because, you ready? We're going to do stoichiometry, right? And we're also going to do mole ratios, right? So we're going to do all of that, and we're going to talk about charges, and we're going to talk about ions, right? Literally, everything's going to just come together. This is literally like the Korean version of bibimbap. You guys know what the bibimbap is? Never mind. Yeah. So moving on, all right? Here we go. Describe an acid. So Kevin says that it dissociates in water, right? So I did say we're going to differentiate between dissociation and dissolving, okay? But we say dissociate, right? Now, to be clear, what is it? Ionic things dissociate. Polar covalent things dissolve, right? So that tells you right away, acids are probably polar covalent or ionic. Ionic, okay? That's important, okay? Right? Like, look at that. We're thinking back to solubility, right? All right, what else? If something is acidic, what do you think? Raise your hand. What's acidic in your life? Go. Low pH. That's how you talk when you walk around the world. You're like, oh, that has a low pH. Oh, Mom, this salad dressing is low in pH, right? Wait, what were you asking? Just acid. When you hear the word acid, what are you thinking? pH. Okay, yes. So apparently, Jonah walks around the world saying that, oh my God, that lemon. Oh my God, why? Oh, why does that lemon make me wince? It's because it's low in pH, son. Right? Right? It's not wrong. What else about acid? I gave you clues. What? That's how you talk to? Somebody says, what? What if you what? Vinegar. What about vinegar? Okay, but what about it? You like drinking vinegar? Okay, why? This isn't 20 questions. Can you just get right? Why do you put it on a salad dressing? Vinegar. Go. What does it add to your life? What? Flavor. Salt. What? What? Sour. What about lemon? Citric acid. What do we like about lemon? It's what? Oh, acids are sour, right? What about base? Yeah, if you remember, I don't know, like most people don't know about base, but if you know about middle school science, maybe you talk about base is bitter, right? Very few things people understand about base. In fact, I have some misinformation. Some kids have come in like, Mr. Kim, base will counter an acid. Like, little Tommy, that's correct. He goes, so since acid is nasty, base is good. No, Tommy, you're an idiot because you can't go home and take a bath in a tub of base. You could, but something funny is going to happen and you'll be made fun of, right? We'll talk about it in a second. Here we go. So let's go with our units. All right, so characteristics of acid, characteristics of base. I'm going to break this down into a chart so it's easier for you to remember, all right? So first characteristic of base, acid is ionic. That means what again? In water, they will what? Dissociate, right? So they will dissociate in water. And what does dissociate mean? You got to remember, right? Like put a little star on the side of your notebook. You're going to write, hey, what does that mean, right? Which means you got some work to do tonight, right? Make sure you understand what dissociate is, right? And know it forever. Next, when diluted, acids taste sour, like in lemon, which is citric, or vinegar, which is acidic. Acids will conduct electricity very well. This is why car batteries have sulfuric acid. Is sulfuric acid good for you? No. That's why I tell you, like when you are trying to jump a car and I see them plug the wires in the wrong way, I cringe. It's happened many years ago, before pandemic. I know it's definitely before pandemic, but I was in the front lot leaving, and I saw a bunch of kids crowded around a Toyota RAV4, guys and girls, and they're literally huddled over an open hood. And I see a cable coming from another car to the other one. And I was like, dude, and I looked, and then, you remember what I said about other regions? Because I looked, did I recognize any of the faces? No. So then, you know what I decided, right? I said, just walk away. And then a voice in my head goes, but what if that battery explodes? Not my problem, right? And then I said, okay, I stop. Look, and I look. I was like, do I recognize any faces? Nope, I don't know any of those students. And I'm walking around. Are you seriously gonna be okay if that battery explodes and then spews sulfuric acid on all their faces? I was like, yeah, not my problem. And in the car, I was like, dang it, you know me, because I'm still a teacher. I get out, and I'm like, okay, they are students. So I walk over and I tell them, and what were they? Sure enough, they were just literally just going to connect it into the battery. I was like, whoa, you can't do that, because if you do that, the spark could make the hydrogen gas. You're going to understand in a second why. Ignite. When hydrogen gas ignites, what happens? It's a bomb. That's fusion, man. All right. Do me a favor. You got it in your leg, open your notebook, right? Instead of telling us something about nuclear fusion. That's not even this chapter. All right. So moving on, right? See that? Some of these are looking at you like shaking your heads, like, how could you, right? Anyway, so it can explode, right? So why is that bad? It can explode, and when it explodes, it'll spew sulfuric acid, concentrated sulfuric acid. And what happens? It'll dissolve skin. How fast? Like instantaneously, right? So 1 year in New York City, kids said, hey, let's take a look. I don't believe you. I think you're lying. That's like the number one thing you say. Whenever I say something cool scientifically, instead of saying, wow, like Max, they'll say, yo, mister, I think you're lying, right? I'm like, okay. And then it's their way to do Google images. And I did. And some of the girls like, oh my God, I think I'm going to be sick, because they look like the Elephant Man. The skin was like melted, these people, right? So look it up on your own. Not right now. I suggest you do it like 2 o'clock in the morning in your room, in the dark, right? Full effect. But acids, they conduct electricity really well. And long time ago, we covered that. When you have aqueous ions conduct electricity because they can move charges. Oh, wait a minute. We covered that in electrochemistry. Okay? All right? And you remember what I said in one of them? I said, you can use sulfate, SO4 2- instead of nitric, NO3. But if you think about it, what's NO3? It's nitrate. What's HNO3? Nitric acid. That's also a very, very strong acid. And this is the reason why. What happens when batteries leak? Anybody have that, where you like have AA battery left in a remote for too long, and you open it up, they get cruddy stuff? And should you get that on your skin? You always do. He always rubs it on his skin, right? Right. So what happens? It's one, extremely sour, and two, it is caustic. It takes a few layers off, right? All right. So and it will destroy your electronic device, right? That's why, because it's acid. It's leaking out. All right, keep going. Acids are corrosive. Speaking of, they are corrosive. They're caustic. They also react with metals to form H2 gas. Oh, Mr. Kim, is that why dead car batteries give off hydrogen gas? That's right, kids, because remember, what is a car battery? What kind of cells? Oh, voltaic. That goes electrolytic and back and forth, right? So what do they have inside? What are electrodes made of? Metals. And what did I just say? You need superconductive solution. Therefore, you put acid in it. What happens to metals and acid? They corrode. And what happens? They react with metals to form hydrogen gas. That's why car batteries are always making hydrogen gas. Normally what happens? It's very little and it actually just wafts away. But what happens when your car is dead and it's sitting there for a while? That hydrogen gas could build up under your engine. And what happens when you go to connect your electrical cord? The last connection, spark, boom. What are the odds of that happening? I don't know. It's like 1 in 10,000. Oh, big deal. Yeah. Do you want to be that 1 in 10,000 though? Right? So be careful with it, right? If you look at car jumper cables, they have a tag on it that tells you the order in which you connect the good car and bad car. By law, that tag can't be made of paper. It's made of polyester, synthetic, so it doesn't rip. And it's like the pillowcase tags. You're not supposed to cut it off, right? But it's the directions are on the cord. All right. Acids change pH indicators to a different color. You already know that. You've tried what? Litmus paper, right? You've used that in bio, right? Turns red or blue, right? Right? How many people know about the red and blue litmus paper? You've used that in class, right? In bio class, right? What's the difference between a red paper and a blue paper?
Color.
Yeah, red.
Red means acidic, blue means basic, right? But what is it? You know, you get the red one and a blue one, right? Did you know they're both actually the same paper? So if you take a red paper, stick it into base, it turns blue, right? Then you throw it out, right? No, you don't have to. If you take the whole paper and dunk, turn the whole thing blue, and if you leave it out and let it dry out, now you got a blue paper. You take that and stick it into red, it'll turn pink, right? So litmus paper, there's no red paper and a blue paper. It's only one litmus paper, and they come red or blue because they were pre-dipped in acid or base, right? What does that mean? Acid or bases will change a litmus paper between red and blue. Got it? More on that as we get to indicators. Acids feel like regular water. True story, right? Another true story, right? Is when you drop acid on your skin or touch it, you won't know it's a chemical because in the beginning it feels like what? Just water. And then after a while, what's it going to feel like? You're going to feel like that water is getting spicy on your skin. And after a while, you're going to realize, holy crap, I feel like it's on fire. And by the time you're like, oh my God, it's on fire, you run to the sink and then you rinse that skin. It's too late. You're going to have damage, right? True story. College, my ex-girlfriend, she was a little weird, smart, ranked number one at Rutgers, right? How smart are you to be ranked number one? There's 32,000 students at Rutgers, ranked number one, right? And then what happened? You know, I was smart, right? Look at me, right? Anyway, so people that are that smart, they're weird, right? So I was like, yeah, I got to break this off with this girl, right? So then what happened? After like a year or two of dating, I was like, I told my roommate, I'm going to do it. I'm going to go tonight. I'm going to go over to her dorm. I'm going to tell her, that's, you know, I don't mind this, right? Right. So I go, and then I go up to her suite. It's a suite with a bunch of other girls living together, right? And then they're all worried. I walk in, and then she's crying in the bathroom. I'm like, what is going on? I was like, she's already crying. I didn't even break up with her yet, right? It's like pre-crying, right? I asked, I'm like, oh, she dropped acid on her foot in lab. We're all lab rats, right? I was like, okay, so ruin their shoes. Because what do you do in lab? Never wear open-toed shoes because what if you drop something on your shoes? So then it's like, oh, no, she was wearing sandals. I was like, that's like, right? I am hearing it in my head. What kind of idiot would wear open-toed sandals in a lab, right? And then, so I go into the bathroom and then, I don't know if you've seen Big Bang Theory, but Sheldon Cooper, whenever he has to be sympathetic because he doesn't know how, he will go, there, right? Pat on the back. That's literally like that. I went in, I was like, there, you okay? He goes, I was like, why didn't you rinse your foot immediately? She goes, it just felt like water. I didn't really think it was water. I was like, wait, what? You dropped? What did you drop? She told me what it was. I was like, well, that's literally, that's a bronzed acid right there, right? Why would you not rinse yourself? Wait, you couldn't identify something was a bronzed acid by looking at the chemical formula? And then now, strike two, right? So what did I think, right? In the beginning, I was like, oh, maybe I'll just come back another. I was like, nope, got to happen right now, right? Got to happen right now because why? I lost all respect. True story. And then what happened? Broke up, right? Figure, hey, you know what? When you do, what happens, right? You go from sad to sadder. Who cares, right? So I came back, right? I came back and then my roommate was like, hey, what happened? I was like, oh, I told him. He goes, wait, you broke up with her? I was like, yeah. And I said, and he was my AP bio partner from high school, right? And I was like, dude, you know, and then I told her, open toe sandals And on top of that, didn't even rinse her foot because she thought it was water, right? It was an acid. And he goes, oh man, that's more the reason, right? So, again, when you get acid on your skin, what does it feel like? Water. Okay, that's why I tell you, don't eat in my lab, because why? If there's wet things by the sink, don't assume it's water. If you're anywhere in a lab and if you touch something wet, do not assume it's water. Always assume it's anything but water. You should always rinse. Okay, don't even wipe it dry. You should always rinse. That's why and then you know me, I feel I'm acting all loosey-goosey, but one place you'll see me very serious is if I'm in the back, I'm doing demos or something, and I touch something wet, you'll see me immediately rinse my hand, okay? Because you can't tell. And here's the problem. When you touch HCl, like Hollywood did you wrong. In Hollywood, what happens when acid lands on you? It burns immediately. Like, what? Because there's a time limit in the movie, and therefore they have to make the effect. They can't wait the 30 seconds to 1 minute of silence, right? Before, like in Aliens, when you get shot and the alien blood hits you, they immediately go, and then they scream, right? In real life, what would happen is the alien blood will hit. You guys know what I'm talking about, aliens? Yeah. Right? The blood is organic acid. So when it hits you, in real life, it'll be like, it's like, Ripley says, or what is that? What's that? Hicks was like, you want some of this? And then the alien explodes, hits them, and goes, yeah, man. They high-five. And then all of a sudden they turn around and they're like, wait a minute. And they go, and then they start. That's how acid works. What do I mean by that, right? Acids feel like regular water when you immediately touch it. If you don't know, think about it. Miss Kobe, I'm sure, adding vinegar into her salad dressing might have accidentally touched vinegar. Does it feel like anything? Just feels like water, stinky water, right? All right, cool. Let's keep going. Acids will neutralize bases. You know that, right? All right, let's move on to basic. Bases are also ionic, which means they what? Yeah, guys. Oh, Mr. Kim, why are you making us say this twice? It's important. It's important. Don't forget this. Remember this. We're going to come back to this. Let's keep going. When bases are diluted, they taste bitter. Soap and laundry detergent. But you knew that because you watched what? Christmas Story, right? What? Really? No one watched Christmas Story with Ralphie? Only one person. What are you? Listen, just stay quiet, sir. All right, so Christmas Story, right? Don't you know Ralphie? You'll shoot your eye out, right? Yeah. So what happened? You remember there's a scene where he's helping the father change the lug nuts, and then he had it on a wheel cap, and then the whole thing falls over, and he goes, "Oh, fudge!" And then he goes, and the narration goes, "Of course, I didn't use the word fudge. I used the other word." And then when the dad tells him, mom's like, and then what is the penalty? He had to stick a bar of laundry. That's a laundry soap, kids. It's not ivory. It's soap. When you do laundry, they used to have hard bar of soap for laundry. So you have to suck on that, right? And that's a thing that was a big thing back in the old days, right? Why did they make you suck on a soap? Because one, it means what? It's cleaning your mouth out. But why else?
Bitter.
It's very, very bitter. Laundry detergent is really bitter. Now, please, I don't want to hear tomorrow like, geez, like, hey, Mr. Kim, I took a chug of the liquid laundry detergent, and man, is that bitter. Don't do that, right? Just take my word. Soap is extremely bitter. Hey, why are soaps bitter? Laundry detergents, shampoos, and hand soap. They are basic, slightly basic. Why? Anyone know? Anyone know? Think about Miss Kobe. What did Miss Kobe say? Miss Kobe enjoys what? Sprinkling some what on her salad? Which is what? Oh, how many people kind of like the slight sourness is a good thing in your food? Just, touch of sourness, right? Like red sauce, little sour, right? Right? How many people like their food to be bitter?
Oh.
All right, salt isn't bitter, dude. All right, so now, you ready? if you spill your salad dressing on your shirt, what type of thing is on your shirt now? Acid. If you get spaghetti sauce on your shirt, what is it? It's acidic. Most of the foods that we eat are acidic in nature because we have evolved our palate to prefer acidic over basic. That's why it makes sense that our soap is basic. It neutralizes. That's the reason why basic stuff works better. Okay.
Why would we like acid?
Why?
Why do we do that?
Why do we like that? Because, man, this is where science has failed you guys. Why do we like that? Because where did acidic things evolve? Plants. It's always the plants. Plants evolve. Some plants evolve to be very, very sour, right? You know, some fruits are sour, right? Why? Yeah, it's a defense mechanism to keep them from being eaten. Where do we get hotness from? Plants. Where do we get spices from? Plants. What are all flavors coming from? Plants. Why? Because these are all defense mechanisms that the plants came up with to prevent them from getting eaten so they can, propagate. But what happened when that happened? Animals, what? Yeah, they evolved with mutation in your taste buds where it doesn't bother you anymore. In fact, what happens, right? Think about it. If G is a piece of lemon, he says, I'm going to make myself super sour, right? What happens? All of us are like, oh, hell no. No, none of that. No, thank you. And then what happens? All of a sudden, Sophia has a mutation where she actually not only is okay with a sour, she thinks sour is actually pretty good. What just happened? She and her descendants' entire source of energy of food opened up to you that nobody else eats, right? So it makes sense, right? That's why, we've evolved to actually like it. The one thing we can't do is bitter, right? So that's really interesting, right? So guys, think about it. Science is fun, man. Bio plants, animals, right? Evolution, right? Receptor molecules, right? Chemistry, all that coming together, right? How fun is this class? All right, bases will conduct electricity really well. Why? Because they're what? What? Ionic, right? They're aqueous ions, right? Good. All right. If acids are caustic, what about base? Good for you, right? No, bases can still hurt you. Not as crazy as strong acids, but they can still hurt you. In fact, here's a fun yeah, what's up?
I was gonna ask, do they conduct the same?
Yep. Yes, but bases, they have a tendency to precipitate. That's why we don't use them in batteries. But more on that later, right? All right, so bases can still hurt you, right? Not as crazy as strong acids. However, fun fact. Main ingredient, okay? And I'm sure it's gonna be the same. 18 years of high school, every year I ask, it's always a boy that seems to know what this is, which I don't know why. But who knows what Nair is? N-A-I-R. Look, see, boy, okay? Boy first, and then, right? And then Haley, right? What is Nair? Raise your hand. Tell us. What is it? Yeah. It's a hair remover. Why? I don't know. Why boys? I don't know. But, right? How does it work? It's a lotion you put on your hair, and then it removes it. How? Yeah, it melts it. It dissolves hair. Completely dissolves hair. Ready? Where else do you find Nair? No, sorry. Where else do you find? So what's the main ingredient of Nair? It's base. All right, it's sodium and potassium hydroxide. Where else do you find base as a main ingredient? Ready? Drano and liquid plumber. Why? Oh, it dissolves hair. So that's why if you put liquid plumber down, a base down the drain, what happens? What causes your drain to be clogged? Hair, right? Hair is the reason why drain is clogged. Just as much as, foam falling is because you're using it in class, right? So ready? Fun joke used to be what? If you put some Nair into shampoo, then what happens? Yeah, right? So could you take a bath in a nice tub of base because it acts against fat acid, it should be good for you? Sure, if you want to come out, you're gonna look like what? A bowling ball, right? Right? However, yeah, you could put Nair into shampoo. That used to be a thing in the 80s and 70s, right? Kids used to play a prank in college. You put Nair, you replace shampoo with Nair, and then what happens is the kid takes a shower, wash their hair, right? And what happened? Next thing you know, they're going bald, right? Their hair's dissolving, right? Right? That's why Nair is what color? Pink. So that if you add it to like Head and Shoulders, it turns purple, so the kid will know, right? So if you're a real science person, and if it's before Homeland Security and before the 9/11 terrorism, where if you pull a prank where no one dies, but they come close to dying, we all laugh it off instead of someone going to prison. What do? You could add Nair to somebody's Head and Shoulders, which is blue, right? And make it purple. Or if you want to be really discreet, what could you do? You could go to lab, get some sodium hydroxide, which is clear, dissolve it, put that into the shampoo, at which point what happens? Same color. Same color. No one knows. And what do we know about bases? All right, check it out. They also change, right? pH indicators, different colors, but here's a biggie. They are slippery. They are slippery, like soap. So no one will know. No one will know. And then what happens? They use the shampoo, their hair starts to get thin. You don't put a lot, right? Because then you know it's dangerous. But you put just enough so the hair gets so weak that they starts falling apart, and then their hair starts coming apart. And then what do? Because you go to college where there's a medical school on campus, you find the most obscure medical condition where there's only one known case in like 200 years, where the symptom is thinning hair. And you print it and you give it to them like, hey man, I'm sorry, I think you have this disease, right? What? You can't do that nowadays. You go to federal prison for that,
Like everybody wants to do that.
right?
What about
Whereas
your
back then it
eyebrow?
was fun. What?
What's your eyebrow?
Yeah, I know it's gone
It's like
too.
your eyebrow.
I know it's cool, right?
Somebody
Yeah,
did tonight.
yeah. It's cool, right? It's cool. I'm not telling you I did it. Somebody did it. All right, so moving on. All right, so anyway, so bases feel slippery. And how do you know? If you put bleach on your hand, if you're cleaning bathroom or something, you put bleach on your hand and then you try to rinse it off, how does it feel? It feels very slippery. It feels like you got soap on your hands, right? But what happens when you rub, it doesn't foam like soap, but your hand feels like you swear there's soap on your hand. So you rub it underwater. What happens? You'll rub and rub and rub, and what happens? It doesn't come off. Right? So I did this thing in AP Chem where I did a demo where I poured bleach on these boys' hands, and then they stick it underwater and they rub, and what happens? It smells like swimming pool and it won't come off. And they're like, oh, come on, boys, rub. And they're like rubbing, and then it still won't come off. And then what do you do with it? What neutralizes base? Acids. So what do? Hydrochloric? No, then I'll dissolve their hand. Vinegar, right? You put vinegar and what happens? So literally, as I'm pouring vinegar on their hands while they're trying to rub, the slipperiness disappears. And kids are like, oh my God. So, Mr. Again, can we do that? No, because I don't want to hurt kids' hands. And then there are girls in the AP Chem class that are so sad. They're like, why won't you let me do it? Because listen, if something goes terribly wrong and let's say some boy's hand burns and then you look like a cauliflower hands, I'm okay with it. But let's face it, right? If a girl ruined their hands like that, I would not be okay with it, right? Can you tell I have a daughter? Anyway, so moving on. So yeah, because I'm from communist China where you can only have one child. Moving on, guys. So moving on. What was I saying? All right, so how about this? Mr. Kim also doesn't like to eat fish because, well, no, that's not true. Mr. Kim likes to eat fish because you're Asian. No, that's racist. But Mr. Kim likes eating fish, but I don't like eating fish because why? The smell. I can't take the smell, right? Not to mention, you prepare fish in your kitchen, everything smells like fish, right? Why? Because the molecule in the fish that smells has a tendency to stick everywhere. All right, that's why when you cut fish with a knife on a cutting board, everything smells like fish. They tell you, oh, use hot water and lots of soap to clean it. No, what do? Bleach. They do tell you to use vinegar, but what works better? Bleach. Why? If you use bleach, so I take a bleach, I get a nice spray bottle, fill it like what? 10-15% bleach. No, let me finish talking. So I put in 10-15% bleach, rest it with water, and what do? After you're preparing fish, the cutting board, the knives, the sink counter, you spray bleach and you wipe it down. What happens? Instantaneously, the fish smell disappears. Why does it do that? Because it neutralized the fish smell? No. You're going to love this. Welcome to biochemistry. Are you ready? It's because bleach has a tendency to cut and change shapes of molecules. Wait a minute. In bio class, how do enzymes work? You remember the baseball glove and the lock and key model? Right. So you smell fishy because the molecule tickles and attaches to a receptor in your nose that tells you it's fishy. So bleach will take that molecule and change its shape, which means, are those molecules gone? No, they're still there. But what happens? You can't smell them anymore because they don't fit your receptor in your nose. How cool is that? Except the problem is, what else? The bleach is now on your hands, it's everywhere, and everything smells like a swimming pool. So how do you get rid of that? So I have a rub it with another piece of fish. Right? No, I have a second spray bottle with 15% vinegar, rest of it water. If you chase the bleach afterwards with vinegar and you wipe it, what happens? Everything smells like vinegar. But what do we know about vinegar? Vinegar completely evaporates, which means if you do that, it smells like vinegar, but after a while, the smell goes away. Bleaching the fish? Yeah. Or how about this? What? Wouldn't it be easier if they fed bleach to the fish to begin with so they don't smell? Ah, smart, right? Just like the old president who said, let's inject some bleach into ourselves, right? All right, here we go. All right. Here we go. 2 theories. Come in, let's go. 2 theories of acid and base. We need to understand how theories work. All right. So there are actually, here, ready to go. There are 2 theories that you're going to have to know. First theory, there are 3 major theories, but we'll only cover 2 in region. First is called Arrhenius theory. Second is called Bronsted-Lowry. And yes, it is true. There is a weird slash through the O. And then third is called Lewis. Regents did them dirty, though. I'll tell you in a second why. Oh, sorry. The third is Lewis. Lewis theory, right? Hey, anybody remember where in chemistry you heard Lewis? Lewis diagram, right? What's Lewis diagram? Lewis diagram was diagram used dots and dashes to represent what? Electrons. So Lewis theory thinks about acids and bases in terms of electrons, but Regents will not talk about it. Okay, so now you know, though. Now you know, right? All right, so let's go to let's go to Arrhenius. So I'll tell you in a second why Regents did them dirty in a second, right? Ready? Here we go. You guys ready? Let's go to Arrhenius first. Arrhenius. I believe it's Svante Arrhenius. Yes. Some Danish dude, right? There he is, right? That's Svante Arrhenius. He won the Nobel Prize. You don't have to write this down, right? That's not important. This part is important, right? You don't have to know he won the Nobel Prize, right? But he based his theory on hydrogen ion and hydroxide ions. So what's the deal? The deal is Arrhenius, during his day, people didn't really know what an acid and base was. They knew by description. They knew that acids are sour. If they're strong, they burn you. They conduct electricity, yada, yada, yada. But he said, how do you recognize an acid if you see a chemical formula? So Svante Arrhenius said, all acids have one thing in common. They are all able to donate hydrogen ions, and bases can donate hydroxide. We're going to get into that more in a second. Okay, ready? Here we go. So why? Here we go. So where will we go see a list of acids? Table K, right? So you go to table K. So if you go to table K, we notice something. All right. So what do we notice? We notice that all acids have H in common. Here we go. These are the acids with H's in common. All right. So now that we have this in common, what do we notice? Right? One, all acids are ionic with an H that can fall off as a what kind of ion? Which makes it what kind of ion? Cation. So, once again, Svante Arrhenius said acids are ionic compounds where it has a H that can fall off as a hydrogen cation. So he just classified what an acid is. So he called so Arrhenius calls acids hydrogen ion donors. You got to know that. Let's move on. All right. So let's keep talking about this though. So by the way, the order is a little wonky. It's because I'm literally going through the order that's in your textbook chapter, right? To make it easier for you to work together. All right, here we go. So let's go. Something else to note regarding regarding acids. All of the acids have H in common, but some acids can donate more than one H plus when it dissociates, as you can see, right? As you can see here, right? Some acids can donate more. Look at this. HCl dissociates. HNO2 dissociates. But H2SO4, when it dissociates, it does one of these jobs. So there's a term you need to know, which is these kind of acids that have more than one H plus that can donate are called polyprotic acids. Example time. I got three acids right there. HNO3, nitric, H2SO4, sulfuric, and H3PO4 is phosphoric acid. HNO3, how many H's do you see able to donate? One. That makes this a not polyprotic, but one means what? Monoprotic acid. So, if the thing has two wheels, it's called a what sickle? No, it's a dicycle. So therefore, if you have two H's, it's called diprotic, just like dicycle. But if you have three available, it's called triprotic, like tricycle. Both di and triprotic acids are known as polyprotic species. Yes, sir.
Usually get more than that.
What do you mean?
Like more than 500.
No. It's weird. You know the flash that we just saw? That's what happened before the weird timer popped up. That started counting
It's
up.
gonna happen.
It's gonna happen. If it does, yeah. It did? The flashing? I know, but then after that, a timer popped up. This time a timer popped up that was counting up to something. That was crazy. And it's like a window we've never seen. Yeah. Yep. All right.
Is it counting down?
No, counting up. And it was like a window. It's weird. It's not on my screen. It was on there. And on top of that, when I hit OK, when I hit the stop button, it goes file name. And I was like, oh, okay. So what do you think I do? I don't know what it is, if it's the board or this or the network. So I said, find me, please. I named the file so that I could search find me, please, right? And then when I went to go hit OK, it wouldn't let me push the OK button. And then I was like, what is going on? And I turn around and I try to grab the remote for the board. I swear I didn't touch a button. I grabbed the remote. I was about to press it. And when it saw me about to press, it went whoop, disappeared.
I did see the song.
Anyway, moving on. Here we go. All right. You know what's more interesting? Yeah, you know what's more interesting? What acids do in water? That's more interesting. Here we go. Again, why did you put water as HOH? You're gonna see that in a second. Well, wait a minute. Some of you are more astute. You just realized something. Guys, Arrhenius acid can donate what? H plus. Arrhenius base donates what?
OH.
OH. Hey, what does water have? It has both. What does that make water?
Neutral.
Why is that neutral?
Because they balance each other.
It's both. Right? It's like Aesop's tales with the bat, right? You know that story? Of course you don't, because you guys don't read, apparently,
I saw that.
right? They have these things called books. They have these thing called books, and if you read it, it's interesting. All right, here we go. So, why does it come up first? Acids donate, or they force somebody else to take an H plus ion. So if Isabella goes around the world and she goes, here, what is it? It's an H plus ion. I don't want it. You know what? You're gonna have to take it. You're gonna take it and you say thank you, right? What is she? She is a very sour person, right? AKA, she's an acid, Arrhenius acid. If Anna goes around the world grabbing H plus and goes, oh, look, it's a straight H plus. Well, thank you very much. And she makes that part of herself. I'm sorry, I screwed that up. If Anna goes around the world, oh man, I just gave away the other definition. Pretend you didn't hear that. So if Anna goes around the world, goes, she forces people to take OH minuses that she pops off, that makes her a base, right? So here we go. So look at this. You ready? Look. Do you see, what's this? HCl. Do you see that? He said, chew acid, right? So HCl is on table K and hydrochloric acid. What should hydrochloric acid do? They should be able to what? Donate something, right? So let me do this. Do you see this? Right? So check it out, guys. Hydrochloric acid donates, right? H, and then what happens? You got left this like that, right? And where's the H? H is right there. Does that make sense graphically? What's going on? So that green H from hydrochloric popped off and stuck itself onto H2O, making H3O plus. We all good? Now you're thinking, oh, Mr. Kim, that's all great, but how does this make this an acid? How does this make this an acid? It makes this an acid because of this. I'm not going to go into details, but whenever you see H3O plus, it's going to be the same exact thing as saying H plus, okay? Why? Let's look at H3O plus. Let's look at a hydronium. Hydronium looks a lot like water, right? What's most abundant on Earth, hydronium or water? Water. So that tells you what is more stable, left or the right side of this equation?
Oh, right.
Right side is more stable. So what it tells you is that most hydroniums, when they form, they will instantly fall apart into H plus again. So if you have one hydronium, you're going to end up with one water and one H plus. If you have 3 moles of hydronium, you're going to end up with 3 moles of water and 3 moles of H plus. That is why this is interchangeable. In reagents, if you see concentration of H plus, it's the same as concentration of H3O plus. If you see the concentration of H3O plus, it's the same as concentration of H plus. You got it? Everybody okay? Just don't ask why. Like the details are that we go into, it's supposed to be honors, but that's enough for you to know. Like reagents like makes you kind of memorize stuff, okay? All right, so acid reacts with water, right? Acid reacts with water to produce hydronium and anion, where the hydronium is your H plus ion. Everybody okay so far? All right, let's keep going. So bases can be seen where? They could be seen over here, right? Table L is a list of common bases, right? So what do all bases have in common? Raise your hand, raise your hand, raise your hand, raise your hand. Somebody new, Ethan. They have an OH in common, right? You remember what Arrhenius said? Arrhenius said bases are hydroxide ion donors. So, oh no, I didn't cover that. Sorry. All right. I gave it away. Right. So these Arrhenius define bases as an ionic compound that can dissociate and donate hydroxide ion in water. What does that mean? If you come across a random bottle with a label with a chemical formula, now you can tell what is what. If you see a formula where you can see it's ionic and you can see an H that can fall off, then it's probably an acid. If you see another label where you see OH and the rest is a cation, you're thinking, oh, this probably donates an OH minus. This is probably base, right? So that's what Arrhenius gifted the world. Bases can also be polyprotic. Please identify polyprotic base. Who sees one? Yes. Which is what? What is that called? How do you know the name? What is that? Calcium hydroxide. Calcium hydroxide is a polyprotic base. Why? It gives off 2 OH minus, right? Per 1 molecule of calcium hydroxide. Everybody okay? Everybody okay? We're going to move on. Yes? All's fine. So this was like great. So they elevate Arrhenius. I don't know he's a big guy, but they lift him up. They parade him around the street saying, thank you, Arrhenius. Because of you, now we know what's acid. Now we know what's a base. And they were happy until what happened, though? Until NH3. What? NH3 is what? Ammonia. What's the problem with ammonia? It is, you ready? If you taste ammonia, what does it taste like? Oh, this brings up another story. Some kid asked, like, I don't know, you know, like many years ago, the Survivor reality shows were like a big thing, right? And then like people like Bear Grylls, they'll tell you like you can drink your pee. No, you can't drink your pee, right? But you know they'll do that on camera just to just like get some audience. And the kid's like, hey, what does that taste like? To which Mr. Kim said a long time ago, I said, this is back in New York City, right? I said, it's bitter. And all of a sudden, what happened? Now kids are going around saying, oh, Mr. Kim drank pee because he knows it's bitter. I'm like, I wanted to, but I couldn't. But this is what I wanted to say to the kid, right? This is what happens when you're so stupid in science, right? That you have to taste everything, right? How did Mr. Kim know that pee is bitter? Because, you ready? Ready? What is the main ingredient in urine? Why does it smell so bad? What are you smelling? Ammonia. In fact, if you get a bottle of ammonia and you open it up and you smell it, what does it smell like? It smells like pee. Because you know the smell in urinal when you go to like the truck stop urinals or the boys' bathroom, and because let's face it, no men actually know how to aim, so they get pee all over the place. And that's or when babies pee or dogs pee, it has a distinctive pee smell, right? What is that distinctive pee smell? It's ammonia that you're smelling. Okay. So how do I know that pee is bitter? Because ammonia is a base. Oh. When Boy Scouts, I asked this in the other class, some of the kids seem to know. If you're out in a wild survival and then you get bit by a bug, what do they tell you? What? Pee on it. Why? Because it's a base and some of the toxins are, hold it, acidic, which means what? It'll neutralize. Does it work? Kind of, right? Right? However, what else do we know? If you get that on yourself, it's slippery. Mr. Kim, how do you know pee is slippery? Again, guys, get your minds out of gutter. It's because, I know why, because it is a base. But I know that it's a base. That's why I'm guessing that's what it is. But ammonia is bitter, slippery, conducts electricity. It is all that. All of what? All the description of base, ammonia fits. Do you see a problem with ammonia, though?
There's no OH.
There's no OH. So that's why people are like, yo, Arrhenius, what up? What up with ammonia? It is a base. We know it's a base. It has the property of a base. It neutralizes acids. It's bitter. It's slippery. Conducts electricity. So it's a base. Why doesn't it have a hydroxide? To which what did Arrhenius say? I have no idea. I got my Nobel Prize, suckers, right? Who cares, right? Because can they take it away? No, they can't take Nobel Prize away. If they give it to you accidentally and you're wrong, they still can't take it away, right? That's the best thing about Nobel Prize. That's why they usually give it out when you're really old, where they know you're correct. But the problem with that is because they wait so long, people have a tendency to die. And one of the other thing with Nobel Prizes, they don't give it posthumously. You have to be alive to get it, right? Yeah, those sweets, man. Right. Anyway, so moving on. So what happened? So what happened with ammonia? Let's go. Ammonia ruins Arrhenius' definition, doesn't it? We need a revised way to look at acid and bases. So this is when, right, what was starting to be cool. Well, during the time of Arrhenius, right? Because think about it, the name like Arrhenius, modern or ancient name?
Ancient.
Yeah, like Arrhenius, right? Whose name Arrhenius, right? So back then, they only knew about large things like atoms and ions. That's why he based his acid-base theory on ions. But by the time people realized, hey, what the fudge, right? What's going on with ammonia, right? What was big? Hey, you guys remember what we covered? We did atoms, we did ions, and then we talked about subatomic particles. Remember we learned about protons, electrons, and neutrons? So what happened was subatomic particles became a thing. So can you guess what happens next? Couple of scientists decided, can we look at acid and bases in terms of a subatomic particles, right? How cool is this? This is what? Atomic theory coming back, right? Right? This is like, this is like the episode where you're like, oh my God, this is from episode 1, Mr. Kim, right? Here we go. Or marking period 1. So a dude named Bronsted and Lorry, they're not married. Bronsted and Lorry, Johannes Bronsted, right? Developed his theory independently with, this is Johannes Bronsted, with Thomas Lorry. You don't have to write that. You don't have to know who these guys are, right? Regents doesn't care about names of scientists, which to me is sacrilege, right? But anyway. So these two guys, so look, does Thomas Lorry look angry? That's Bronsted. Does he look angry? No, he looks displeased. Why? Because he's like, dang it, I have to share my discovery with Lorry. What about Lorry? Why is he so angry? Because here's what happened. If Haley and Sophia co-discover something at the same time, and you start fighting, there's like, hey, who gets the credit for this great discovery? And he goes, me. I discovered it. And Sophia goes, no, you Peach, right? It's me, right? And he goes, what'd you say, Peach? Because I said, you heard me, right? And what happens? Do they start pulling it? No. What happens is, then we go, okay, let's look at their notebook. Anyone taking engineering classes, notebooks are important. So what happens? You look at the notebook and you look at the dates of the discovery and you realize, oh, wait a minute, it's at the same time. So what do? They both have to share the discovery. In that case, what happens? Will it be called the Ryan-Champion model or the Champion-Ryan model? It'll be Champion-Ryan model. Why? It's alphabetical. Oh, yeah. Did you know that? In science world, if you make co-discoveries and you fight over it and then you get both credit, it goes in alphabetical order, which means that which is the reason why I said, had Mr. Kim stayed as a scientist, I would have changed my last name to 00KIM. Because you can't, right? Like, I'll be the first person, right? I even said, can I use like ASCII characters, like a smiley face, right? In front of my name, right? That's why when Elon Musk was like naming his kids using like symbols, I was like, oh, that's cool, because but then no, that's not cool. It's the last name that counts, not the first name. So he's not cool, right? But anyway, so that's what happened. Bronsted Lorry made the discovery. Why is it Bronsted first? Because his letter comes before L. And here's what happened. Do most people call it Bronsted Lorry acid base anymore? Nope, they call it Bronsted. Right? So in the end, the discovery will be called Champion-Ryan, right? And then after a while, it'll be called, right? It'll be called Champion. Everyone's going to forget about Ryan. Okay? So anyway, You think that's bad, right? You think that's bad. It's even worse because what happened with regions? They don't even call it Bronsted-Lowry. They decided to call it the alternate theory. What? It's not even a thing. In New York State regions, they call it the alternate theory versus the traditional theory. It's the dumbest thing I've ever seen. All right. So I'm going to go back for a second in your notes. Right here. Sorry. Holy smokes. Oh my goodness. All right, here. So in New York State regions, you might see this as traditional theory and alternate theory. It's the dumbest thing because is it an actual chemistry thing? Nope, New York State regions made that up. So therefore, they've been pivoting away from it. So in the more recent questions, they've been using Bronsted versus Arrhenius. But don't be surprised if you come across a question where they say the traditional theory versus alternate theory, right? It's the dumbest thing I've ever seen. It makes absolutely no sense to me, but that's New York State regions. All right, so moving forward. All right, so what do we got? All right, here we go. Bronsted-Lowry. Bronsted reclassified or redefined acids as proton donors. And he said bases are proton acceptors. Notice what happened. Hydroxide ion is gone. We don't look at hydroxide ions. Secondly, we're still using H+, except we don't call them hydrogen ions. We call them protons. I'll show you in a second why. Why is H+ a proton versus hydrogen ion? Because let's draw a picture of the most abundant form of hydrogen. I'll give you time to catch up with your notes. Oh, you guys remember that? Hydrogen, isotopes. Oh my God, Mr. Kim, isotopes are coming back. This is like Christmas, right? Or Hanukkah or Kwanzaa, depending on what you celebrate, right? It's like it's all the gifts are coming back, right? You remember protium, deuterium, and tritium, right? H1, H2, and H3. Oh yeah, isotopes. And the most abundant hydrogen is the H1, which is protium. So let's go. Let's look at protium. If I have a pen. Protium. Let's look at protium. All right. Protium is a hydrogen, right? What's the atomic number of hydrogen, folks? What? All right. So that makes how many protons? 1 proton. How many electrons does a hydrogen atom have then? Also has 1. Considering the protium is H-1, right? Atomic mass number of protium would also be 1, which means proton plus neutron is 1. So that makes neutron how many? Right. 0 neutrons. Can we draw this? Sure we can. Let's draw our nucleus. In our nucleus, how many protons do we put in there? 1 proton. How many electrons are going around? Okay. You ready? That is our protium or hydrogen. How does it become a hydrogen ion when a hydrogen what? Loses an electron. So it'll be left with its nuclei, which is what? 1p. And what happens to the electron? It's gone. So, kids, is this a hydrogen ion? Yes or no? Yes. However, what is hydrogen ion made of? A single proton. So an H+ can be seen as both hydrogen cation or proton. And that's the big thing with Bronsted-Lowry. Bronsted-Lowry decided that acid is something that can give off a proton and a base is something that can accept a proton. Yes, sir.
What is the difference between just 1 proton and that hydrogen plug?
There isn't. It's a functional definition. Well, functional is the same theoretical. But the big difference comes here in how bases are seen. Okay? Here we go. So let's summarize, shall we? Arrhenius said acids are what? Acceptors or donors? Donors. In fact, Arrhenius, everybody's a donor, right? But what did Arrhenius acid donate? Hydrogen ion, which is H+. plus right there. Okay. Oh, this is a chart that's probably going to be the most important chart you should ever know. Oh, so it's in the reference table, right? Nope, it's not in the reference table, right? All right, let's go to base. Arrhenius. Once again, what are Arrhenius? Anything? They're all what? Donors or acceptors? Donors. But what does Arrhenius base donate, kids? OH minus or hydroxide ions, right? It's not that difficult, is it? Right? Arrhenius, both are donors. They donate H plus or OH minus. They donate ions. Let's go to Bronson Lowry. Bronson Lowry donates, is that a donor or acid is a donor or acceptor? Still a donor, but instead of hydrogen ion, what is it donating? What is that called? What do we call it? H plus is what? AKA? Proton. So the proton donor. Oh, Mr. Gibbs, this is stupid. Why? Why? Because look, it's the same thing. I understand that. That's literally what Jonah was telling me, but it's the same thing. Ah, but where's the big change? The big change comes in the form of a base, because a Bronsted base is now what? Is it a donor or is it an acceptor?
Acceptor.
It's an acceptor. And what is it accepting?
Proton.
Known as what?
Proton.
Proton. It's a proton acceptor, right? You got to know this chart, kids, because they're going to tell you. They're going to be like, which of the following could be considered a base in an alternate theory, right? You're like, oh, alternate theory, Bronsted, right? He's like, base. What are we looking at? Proton acceptor, right? You're thinking, well, Mr. Kim, you still don't explain how proton acceptor works. Let me show you. Well, you guys finish writing. You guys remember, kids? The one that threw off Arrhenius is because of ammonia, right? Hey, is there something else that sounds like ammonia, that looks like ammonia, but it's spelled a little bit differently? It's called ammonium. Ammonia could also be ammonium. Anyone know the formula for ammonium? NH4 plus, because it's a polyatomic ion, right? Table E. Oh my goodness, don't you love this lesson? We're literally using all parts of the reference table. How cool is this, right? This is like Umbrella Academy when everything started happening, and then they went to crap, right? But, you know, like, is it season 3 or season 2? Anyway, moving on. You guys ready? You guys ready? Here we go. So how does fix ammonia? Check it out. You got ammonia right here, right? It's base. According to Bronsted, it should what? Give a proton or take a proton? Take a proton. Who is it going to take it from? What's abundant around us? Hello, what's around us? Water. So ammonia is going to go up to water and it's going to like, yo, hey, you. So if Isabella is ammonia, she's going to go up to Anna, the water, and it's like, yo, what? Give me your proton. And then Anna's like, I like being H2O. And what does she do? Isabella, the ammonia, is going to smack up the side of the head. Goes, you like that? Because if you don't, you're going to give me a proton. And what does water do? Water goes, okay, so gives it the proton. If it steals a proton, what's NH3 plus H plus? NH4 plus. That's how you get ammonium, right? You get ammonium. This is ammonia. Hey, but check it out. Well, do you notice something? When ammonia turns into ammonium, what did it force water to become? So according to Arrhenius, it's still a base. It's just that the hydroxide was hidden in a form of water, right? So it's still there. So what I'm trying to tell you is whatever is classified as acid or base in Arrhenius will also still be base or acid in Bronsted. Never will you get a case where something is considered acid according to Arrhenius, but considered base in Bronsted. That should never happen. If it's an acid according to one theory, it's an acid according to the other theory. If it's a base according to one theory, it'll still be a base according to the other theory. We good? Question, yes.
Take one hydrogen.
In this case, yes, because that's a good question. When was the last time? If we take another hydrogen, it'll be what? NH5 plus 2. When was the last time you seen the chemical formula? NH5 2 plus, right? Go with your gut instinct. You know what I'm saying? When was the last time you saw, if you take, and then those kids are like, oh, Mr. Kim, right? This is another big one, right? So therefore, what happens? I can't write it. I get it right here, right? So can NH4 plus take water and then do NH5 2 plus and OH minus? The answer is no way. Why? Because this does not exist. How about another question? Mr. Kim, ammonia has all these hydrogens. So what, couldn't it just give it up? So if ammonia gave up a hydrogen, a proton donor would be what, according to Bronsted? Acid. So a kid could be like, hey, could this be an acid? Because couldn't you have that? Well, guys, ask yourself the question. If it gave up an H plus, it would be NH what? 2. But it lost a plus, so therefore it's now charges minus plus H3O plus, right? Now, the question is, have you ever seen this? Right, because if you take a look, do you see a charge? Do you see a bunch of atoms here? This looks a lot like what? Polyatomic ion, right? Do you see this on a table of polyatomic ions? No. So therefore, what do we know? Can't happen. Right? So understand this. Just because you see a hydrogen present doesn't mean it's donatable. Some hydrogens are integral part, right? So let's say like, you know, Sarah might be going around the world and she has all these hydrogens coming off of her, right? Right? And then let's say Gabriella also has hydrogen, right? When you ask Gabriella, hey, can you donate one of your hydrogens? And she goes, oh, of course. And she goes, because it was an earring. Gives it out. Does she live without an earring? Yes. But then when you ask Sarah, it goes, oh, you have all the, it goes, can you donate a H plus? And she goes, no way. But you have so many. But you realize, what are H pluses? Like her eyes, her ears, her toes. Can she cut those off? So understand that certain H's are actual part of the molecule that cannot be released as an ion. What is a prime example? Acetic. HC3, C2H3O2, right? What is acetic acid, right? Let's go back for a second. If I can go to the table of acids and bases, right? Hey, look at acetic. Do you see that? Right here? What do you see? Right? CH3COOH, right? What's the problem with this? How many H's do you see total? 4. So you would think that this would be polyprotic, right? The answer is wrong. Why? Because it's CH3COOH. Let's say you have it with water. Let's see what happens. You know that if a hydrogen pops off, this would become H3O plus, right? But where would the hydrogen come off? You could either say it's CH2COOH minus or CH3COO minus. And you're thinking, well, how do I know which is which? Where do you go? Guys, these both start to look like what? Polyatomic ions. So if you go to your table for polyatomic ion, can someone tell me if you see something? Oh, the second one. This is in table what? What's polyatomic ion? E? Does this exist in table E? No, it doesn't. Right? So therefore, we know this is the correct way, which means what? Which hydrogen is popping off? That's right. That means this is the hydrogen that pops off, right? Which means how many hydrogens can acetic acid donate? Only 1. Because CH3COO minus, those 3 hydrogens are integral part of the acetate ion. That doesn't fall off, right? So they could ask you, which of the following is a polyprotic acid? A, H2SO4. B, HNO3. C, CH3COOH. 4, KCl, right? And you say, okay, well, 4, KCl, that doesn't even make sense, right? cross that out. And then you realize, wait a minute, HNO3, that's one hydrogen, cross that out. And then now you got H2SO4 and CH3COOH. You're like, wait, both of these have multiple hydrogens, right? How do you figure it out? Well, look at, you got to dissociate it. That's why, remember the equations where I used to tell you need to learn how to dissociate and write ionic equations? That's also coming into play. How fun is this? All right, we will stop here, guys. Thank you for paying attention. Right, make sure you're reviewing your redox and electrochemistry. Have a wonderful, wonderful rest of the day.